So I'm about to start back on this Paddle Battle board. I found another schematic for the cabinet diagram, wiring diagram. Here they're showing clear indication of the coin switch, and I have wired that up correctly. The slam switch here is completely bypassed. They're shorting pins 7 and 22, which I have not done. So when you look at the original schematic, it shows a switch there. Right there. So the slam switch here, this is correct. I was wrong in the previous video. This slam switch is correct and this coin switch is correct, and I wired it up correctly. This guy here, they eliminated the switch, and pin 7, which is the slam input, is basically being shorted to pin 22, which is going to be ground. So let me add that short to my test harness and see if that makes any difference. So I've shorted the slam switch to ground, and this is what we're getting for the picture. Still not syncing, so that's not related to the slam switch. I need to figure out how to improve the sync, so let me focus on that. After that, I'll deal with the ball moving very fast in vertical direction. I don't know if that's right or not. Might be related to the sync if something in the vertical is messed up. Let me take a look. All right, I need to shift gears here a little bit. I'm not having any luck figuring out the sync yet, but we know the sound's not working, so let me focus on that. These schematics are hard to read. As best I can tell, this is the output here for the sound, C1 pin 6. Now, I've checked to see if that had a signal on it, and it doesn't, but it looks like there's signals on the input. So this chip here is not working, or there's something on this line, but I ohmed out this line, and it seems like there's nothing preventing it from going, from changing state. It's stuck low all the time. In other words, it's not shorted to ground. So let me try changing this chip C1, which is right here, this chip here. Let me try replacing that and see if we can get audio working. And once we get audio working, maybe the sync will be better. I doubt it, but maybe. Let me give it a try. All right, so there's the old chip. I got a new chip in there. Let's see if we have sound now. This was an oldie but a goodie, made in 1973. Wow, 10th week of 1973. That's an antique there. All right, still don't have sync. Let me try reversing the sync. No, I mean, we've got a signal. Well, no, it's still weak. All right, let's see if it has sound. Yes, awesome. We have sound. Okay, well, found one bad chip. Now I just got to figure out how to make the sync better. One of these chips must be weak. All right, let me continue. Hey, so, bam. I've got a steady picture. And the way I fixed it, or the way I improved it, was there's a resistor here that, if you look at the schematics, is right here. This is a 2.7. It shows 2.7 here, but it's actually a 2.2. Part of the problem with these schematics is it was hand drawn, and then it was photocopied, and it's just horrible. That probably is a 2.2. It looks 2.7 to me. This here is supposed to be E4, and it looks like E2. I mean, it's horrible. But I figured out that this inverter is at E4. I figured out that this is a signal is the sync, is related to the sync. It's coming from A411, but you can see the schematic doesn't show it. It's just floating there. It does show it on a different schematic, though. Let me see if I can find that. It's buried, for sure. Let's see, which schematic was it? This one right here. So there's the same inverter, and this is apparently the video output. There's the A4. This is an exclusive, or it's the 7486. All this stuff is working. There's a signal there, and it's good and strong and clean. But that resistor, 2.2 is what it measured when I took it out of circuit. This 2.2 is just too much resistance to let the signal get through on a modern monitor. It may be fine for a TV, And I would think this would be fine for a TV too. And what I did was I just I shunted a 1K ohm across it. And I'm going to leave it, but if anyone ever wants to use this in an actual cabinet with one of those old black and white TVs, you might remove that and you might leave it in. It probably wouldn't matter. Anyway, so we've got a stable picture. Now you'll notice this is off center. There's no adjustments to go left and right really. There is some horizontal positioning, but it wouldn't be enough to move it, I don't think, all the way to the center. Let's see what I can do. Oh, this is difficult here. My problem is I'm half blind. Okay, so you see, it is moving it, but that's as far as it's going to go. And that's maxed out, so I'm going to put it back where it was. Now, I might want to change the crystal. I might want to change the crystal right here. I forget what... Oop, I just started it with shortened to the crystal. That's interesting. Let's see if I can find the schematic for the clock generation. You'll notice though, as this thing plays, there's no vertical boundaries. So that's a problem. I need to figure that out. I've not seen one of these games played. Maybe I should look on YouTube and see if there is a vertical boundary, but it seems awful strange that it wouldn't have one. So that's broken. I'll need to fix that. But really, not much was wrong with this board. Sound audio was one bad chip, got it. We had several missing other chips. Most of my problems was I didn't have the connector. My test harness wasn't correct. Where is it? Come on. No. It was on the first set of stuff that I printed out. Okay. So it's got a 14.315 megahertz. I have not looked at this to see if somebody changed it out. It's probably correct, but I could put like a, I don't know, maybe a 18 megahertz or something. And that would shrink the sides in. It would also shrink in the vertical too, but the vertical could be adjusted. Vertical size is more adjustable than the horizontal width. Horizontal width on monitors is usually kind of a hardware thing where you add and remove high voltage capacitors. So yeah, I might try putting a faster crystal on there just to see if I can get it better. But then again, if you want to use this in an original application, it's not gonna work. Also, putting a faster crystal would make the ball move faster, so there's some side effects. All right, well, I'm going to start looking at the vertical now. Why we don't have these, the horizontal top and bottom vertically placed lines, boundaries. I don't know if there's supposed to be a solid line there, or if there's no line and it's just supposed to bounce off the walls. But I mean, it's doing some weird shit there. All right, let me continue. Well, just for fun, I decided to put an 18.4 megahertz crystal in there, and bam, that's what you get. So that's too much. I was just guessing at the frequency. I guess more like maybe 15 megahertz, something quite a bit slower, I suppose, would do it. But yeah, I just thought I'd share that. I'll put the original crystal back in. Not sure what happened, but it looks like things are working properly now. I cleaned up some flux on the board and I reflowed a few solder points, some vias, but I don't think any of that had any bearing on this. It just started working. I was probing around, I looked up and it was working. And by working, I mean the ball is bouncing off of the top and the bottom walls now, and the speed of the ball is looking correct to me. So let's play a game. I'm going to try to hit the ball. Now, you'll notice that the controllers only go halfway up. That's because these I'm using Atari controllers. These are not voltage dividers. These are just resistors, variable resistors. If you look at the schematics, let's see here. Where are you guys? Okay. So this circuit here shows how it's supposed to be hooked up. Each one of the paddles in the cabinet is basically a voltage divider. You've got 5 volts on each one of them and then the common ground. So as because there's voltage across the entire potentiometer, as you use the sweep, as you sweep across it using the wiper, this voltage varies. On the Atari paddles, there's no 5 volts. There's just a ground and the sweep. So you're getting a resistance between your paddle signal and ground. That's it. This needs to be a voltage divider for this circuit board to work properly. I may take one of these apart, or I may take these apart and add a connection to where it becomes a voltage divider. It would simply be adding a wire to 5 volts in each of them. Let me see if I can do that. I cracked open the controllers, and I had already done that in the past. I had forgotten I had done that. So they are voltage dividers. Without that, the controllers would probably not work at all, actually. So I've got a problem, though. I don't know if it's a circuit problem or if it's a problem with the difference in resistance. No, it should just work. It's a voltage divider. So the paddles, as you can see, don't go full. They don't go all the way down. But I have an adjustment here. Okay, so I can get that one to go all the way down. But it acts kind of weird in the center. It gets stuck in the center, but it is going full length now. How about the other side? Let's take a look. Okay. So that's weird. Okay. Let me see if I can adjust this one. Alright, so that's all the way down there. Okay, so both sides do the same thing. They get stuck in the middle. That may be fine. Maybe these controllers have like 1 mega ohm potentiometers, and the schematics show it needs a 5K. But it's a voltage divider, so I don't see why that would matter. Let me study the schematics, but I think we're pretty much done with this board. If the controllers are working properly for what I have, available here, these Atari controllers, then that's it. If there is a circuit problem, it would be in this section here, these two 555s and all this capacitors, and I don't think the transistors have anything to do with these old transistors. Maybe the capacitors are old and leaky or something. It's causing problems, but it seems like it's working. It just gets hung up in the middle. All right, let me look at it a little bit more. All right, so this schematic tells the story. We've got a 555 that needs a voltage to control the output. To control the outputs, and that voltage is not a simple voltage divider. I mean, we've got resistors here that mess with it, and we've got a resistor there that messes with it. These things are tuned for this to be a 5K. And the Atari controllers, I have a 1 mega ohm, so it's, what, 200 times more. So it's strange. But if you put a scope to it, I'm just going to pick one of these, if I can get it to stay there. All right, so it's staying. So if I turn the knob, see, it's all the way high when I turn it all the way clockwise. Now as I come off it counterclockwise, it gets stuck right there. I'm still turning it. And then after I get even a little bit further, then it gets into this part. So the circuit board is working based on what it's getting from the controller. So the board itself is not the problem. The problem is my test fixture. It's kind of surprising to me that it works that way. I'm not exactly computing in my head how this is working, but I think it's correct. And the fact that both the left and the right paddles do the same thing pretty much confirmed that it's just basically on my setup. If I was to create a new circuit with a 5K ohm like this, I bet it would work just fine. Maybe I'll do that. Maybe I'll make a little circuit board and do that in the future. But as far as I'm concerned, this board is finished. We got audio, we got video, the sync's working. The game plays, paddles control. It's there. Seems to be working beautifully. That's it for this video. Thanks for watching.